Hi everybody, let's go over the scoring guide and my work for 2016 AB3. All the material inside of here is fair game for the 2020 exam. This is all through differentiation techniques. And even though there's an integral in here, it's not an application of an integral. This is all fair game. So hopefully you read this problem and saw immediately that this was a roadmap problem. So hopefully on your paper you have your roadmap listed up above. So it's there for not only you, but for any of the readers ready to go. And I don't know if you would have done this immediately, but at some point you probably would have calculated all of these areas inside of here. So I just left them as positives, just as actual area. We'll let the fact that some of them are negative or below the x-axis, we can deal with that later on in the problem. So pretty typical questions. We've seen problems like this multiple times. Again, I'm going to be sending you all of your free responses back for you to take a look at because I scanned them at school before we left. So let's see what A is. Does G have a relative min, max, or neither at 10? So in order for G to have a max min, the derivative, remember, has to be equal to 0 or undefined. So I check what G prime of 10 is. Well, G prime is F, and F of 10 is 0. It's just literally that point right there. So that's good. So that's that means I'm in the game. If this was not 0 or undefined, then done, game over, it's neither. So I'm choosing to do a second derivative test. I want to check what the concavity is. So I looked at G double prime. G double prime is F prime, and F prime of 10 is, F prime of 10 is undefined. I've got this sudden change. It's a sharp point. So it's undefined. I have no concavity info. So I got to go back to the first derivative test, checking some points on either side. So I made myself a little sign chart. G prime of 10 is 0. That's what I knew already. And now I want to find G prime on either sides of 10. Well, what is G prime? G prime is F. F values. So what are the F values on either side of 10? Well, they're negative and negative. They're literally below the x-axis. So I'm not looking at slopes. I'm not looking at F prime. I'm looking at F. And since it's negative and negative, there is no sign change. The original function must have been decreasing with the 0 slope to decreasing, maybe looking something cubic-y like. So there is neither at that particular point. All right, part B, does the graph have a point of inflection at 4? Well, points of inflection by definition, and let me check, scoring guide. So let's see what the scoring guide says here. So 1 point for the answer with justification. But notice you're actually getting a point for this relationship that is in all of these parts of the problem, but since you made a roadmap, you automatically got that point. You've made that connection. So you're within this problem right now, as we say when we're scoring your papers. So 1 point for that one. You had this 1 point for saying neither because of the fact that it's negative values within that interval from 0 to 12, or 8 to 12, I should say. Part B, does it have a point of inflection? Point of inflections are places where the graph changes concavity or the second derivative changes signs. So I made myself a second derivative sign chart. And second derivative of G is the first derivative of F, so it means I'm looking at slopes up here. So at 4, I've got an undefined slope, and that's fine. There's nothing, we don't have to have any information technically about what's happening at 4. I'm looking for those sign changes. Well, F prime is positive slopes of F, and negative on either sides of 4. And it doesn't matter if it goes positive, negative, negative, positive. There is a sign change. So there's 2 ways to justify this. So yes, there is a point of inflection at x equals 4 because G double prime, which equals F prime, I'm just repeating what I said up there, changes signs. That's based upon what I said here. Or you could say that G prime changes from increasing to decreasing. Now remember, G prime is the graph of F, and the graph of F goes from increasing to decreasing. So you could say that as well. I like this justification, but either works. And if you read the scoring guide, this also too is also worth 1 point. It does have a point of inflection because G prime, which equals F, is increasing and then decreasing within those intervals. Part C now asks for absolute maxes and mins of the graph of G, not the graph of F, but the graph of G. So hopefully you knew that this is going to be a candidates test. So we're going to do a candidates test. And what are my candidates typically? They're the endpoints, because they did include the endpoints. Make sure you look carefully. They did include endpoints. And the zeros. Well, this has a bunch of zeros. In fact, it has 1, 2, 3, 4 zeros. However, save yourself some time here. I don't have to look at all of those zeros. I only want to look at the zeros where there is a sign change. Because if there's not a sign change, then I can't possibly be a max or a min. Remember, this is reading the graph of F, which means I'm looking at derivative values. The derivative needs to change signs to be either a max or a min. Possible max or min. So in my table, I've got my endpoints, and I've got -2 and 6, the two places where I do cross. Now, frankly, as I get started here already, I probably already know what they're going to wind up being, because this is going from negative to positive. So that's going to be a min, decreasing, increasing. This is going from positive to negative, increasing, decreasing. So therefore, I know that's going to be a max. The question is, are those the absolute min and absolute max? So I got to compare them to the endpoints. And so I need to actually calculate some values. So we'll talk maybe about 1 or 2 of these here. At -4, I would then be finding the value of the function y equals, or g of x. So how do I get g of x values? Well, I have to integrate from 2 to whatever that value is. So g of -4 is going to integrate from 2 to -4. But that's backwards, so I'm going to switch the interval from -4 to 2. Now that's going in correct increasing order, but that means now I have the opposite. So if I integrate this from -4 to 2, I've got -4 plus 4 plus 4. So those two cancel each other out, so I would have 4, but because of the switch of the interval, I get a -4. Peek at another one here. -2. So I'm going to integrate from 2 to -2, which means I'm going to switch from -2 to 2, but now I have the opposite. And from -2 to 2 integrates to a value of 8, but it'll be -8 because of my switch of the interval. Oh, what the heck, I'll keep going. These are easier because now we're going to be integrating from 2 to 6. From 2 to 6, that's just going forwards. It's already in the order that I like it in, increasing order. So that's obviously just 8. And from 2 to 12, well, 2 all the way to 12, the 8s are going to cancel each other out. +8, -8, -4. So I'm overall getting a -4. And once you have the candidates test, it's super easy after that. Max and then min at those certain values. Be careful. They want to know what is the absolute maximum and what is the absolute minimum value, not where are they. So the absolute max value of 8 is at 6, and the maximum absolute min value of -8 is at -2. And that was worth 4 points. So the fact that you even considered -2 and 6 as candidates, even though you might have also considered 2 and 10, that's fine, but that gets you a point. Considers the endpoints, that gets you a point. And that's literally, even if you calculated them incorrectly, you get 2 points there. The other work that you're now doing in calculating those values and doing that comparison, that's the other 2 points. And there's a lot of information here, but just in general, if you made your table and got those values and identified those, you got those 2 points. And then the last one's really nice and simple. I'm glad they asked this after what they did in part C, because it makes part D pretty easy. I want to know on the entire interval from -4 to 12, find all the intervals where G is negative. And remember, G is integrating from 2 to x. You can't simply just look at the graph of F. It's the integral of F, but from the interval from 2 to x. This would be super easy if it was going from -4 to 12 or to some x value, because then anything that's below is going to be negative, anything that's above is going to be positive. But I'm going from 2. So going forward is easy. Integral from 2 to 6 is going to be positive. Integral, it's going to generate positives. G of 3 is going to be positive. G of 5 is going to be positive. G of 6 is going to be positive. G of 7 is going to be positive because I'll have 8 minus a little bit. G of 8 is going to still be positive because then it still hasn't completely canceled out. G of 9 is positive. G of 10 is positive. Once I get to G of 10, now I'm at 0. That's going to have a value of 0 because this and this will cancel. G of 11 is now going to be negative because these two will cancel and I got negative, and G of 12 is going to be negative. So anything from 10 to 12 is going to be negative. Well, what happens when I go backwards? Well, integrating from 2 backwards, well, this is positive, but I'm going backwards, so that'll be that switch of that interval, which I can see what I did down here. That'll give me negative 4. Going backwards even further to negative 1, that'll give me even more negative. Even more negative. Even when I go past negative 2, I now have a G of negative 2 is negative 8. If I keep going backwards, now it's going to wind up canceling out some of this, but I had such a big negative value of negative 8, it's still never going to get back to a positive number. So that's why everything from negative 4 to 2 is a negative value. That's worth 2 points, probably because of each of the 2 intervals. Whether or not you included them or not, you really should include them. I know a lot of times they aren't as picky about including the interval endpoints or not. This one they might be because they are including them up here. So make sure they are inclusive. And you knew some of them anyway because of your table. G of negative 4 was negative. It's sitting there right there in front of you. G of 12 is negative because it's sitting there right in front of you. So there you go. Hopefully you did pretty well with this one because we've seen this a bunch of times. It's been a little while, so wanted to pull it out, an old one that we haven't done for a little bit. So make sure that you score it and then give me your scoring guide and let me know how you did. All right.